Hi there, this is Verb, lecturing over section 9. Let's grab a pen, that would be a nice step. 9.6. This is the unit circle that is probably the best. It's got all the tangents, got your x's and y's, got radians and degrees. It is pretty awesome, pretty fast. Anyway, I want to look at sine. So y equals sine x. If I was to graph it, I'd make an xy table. And I'd look at 0, 30 degrees, 45 degrees, 60 degrees, 90 degrees, just for starters. But if you have a unit circle, you just read the y coordinates. 0, 1/2, sine 30, 1/2, we'll memorize it. Sine 45, square root of 2 over 2. 60, square root of 3 over 2. And 90, 1. Now, I know the square root of 3 is 1.73-ish. Therefore, the square root of 3 over 2 is 0.86-ish. So this is 0.86-ish. I know the square root of 2 is 1.41, so the square root of 2 over 2 is 0.705. Now, I rotated through the first quadrant. I also know sine is all students is positive in the first and second. So it makes sense that if I went 120, 135, 150, 180, all the angles, that these values would just simply repeat. And at 180, let's be careful, sine is the y coordinate 0. And then dot dot dot, same thing but only the negatives. So what we need to do is plot those points. So when we plot those points, we go 1, 2, 3, 4. Let's do the first 90. Now we got to bust 90 in half to get 45. Now to bust 45 into the 30, you got to go 3-tick it. No, so this is the 30 and this is the 60. And let's say this is 1. At 0, it's 0. At 30, it's 1/2. At 45, it's 0.7. At 60, it's 0.86. At 90, it's 1. Now, 135, little tick left, tick right, 1/3, 1/3, 120, 150. Symmetrically, kaboom, 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 and then 0. And then, doesn't take rocket scientists to figure out sine looks like this. Granted, I already gave you the graph of that, but you might as well wait till you get through the unit circle to quick plot some points because it's the fastest way. And the book is actually already graphing. I hope you know that usually we're chapter 3 or 4 before we're graphing. This book moved it up to like first chapter. I am 100% in agreement with their strategy. So there it is. Live it, learn it, breathe it. You know, able to do that all day long. You know, but in practice, we only plot this point, this point, this point, this point, and this point. 2 easy points are those 1/2s, for sure. If you want to get those in there, that would help your graph look maybe a little nicer. Well, anyway, that's y equals sine x. Now, obviously, 1, 2, 3, 4, cosine x, like I said, memorize it. But obviously at 90, and there's 45, and there's some special ticks, and this could be 0.86, 0.70, 1/2, etc. So this is going to be 60. So y equals cosine x is this graph. Once again, the 1/2 are cool to get in there. Maybe your negative 1/2, you could figure those out. Also, the bottom line, this is the graph of cosine x. Now, I've probably done that 19 times faster than the book just did it, but we've been working with it a little bit. Now, the book literally takes about 12 pages. What do you say we do it in one? I'm going to give you the V of x formula. That stands for Verbsky formula. It's A trig, standing for any of the 6, bracket, same as a parenthesis, omega x plus or minus b, bracket, plus or minus c. Now, this is the vertical scale. It's the vertical flip. Now, what I mean by that, if A is less than 0, meaning negative, the graph has a vertical flip. This is the frequency, sorry. Plus, I know you right-handers want to say it's a positive thing, but nope. It means left. I'm a lefty. I think it's a positive thing. It makes me right brain, give me a little edge in math some days. The minus is move right. And this plus is what you think it is. It means up C. Minus means down C. So, everybody and their mother, grandma, whoever, can shift a graph right or left or up or down. So, graphing isn't going to be that bad. Now, the vertical scale, vertical flip button, and the frequency button need to be explained. Now, that we're here, we're going to say P new, which stands for new period, is 2 pi over omega, or 360 over omega. Currently, the period for sine x, cosine x, their buddies, cosecant x and secant x, are 2 pi. Because it's sine 1x, where omega is 1. And you can plug a 1 in there, it's 2 pi. What is the period? Well, the period is the length of one cycle. And you already know that sine and cosine repeat every 360, every 2 pi, from here to here. Frequency, omega, we say, if it's 1, which it is here, it frequents 2 pi once. How frequent does it visit 2 pi? How frequent does it visit 360? That is when omega equals 1. Now, if you got y equals sine 2x, it just says that frequency is 2. That means 2 visits per 2 pi, or 2 visits per 360 degrees. So I can graph that. 1, 2, 3, 4, 360. let's put double the ticks in, and let's graph sine so it has two visits. One visit, two visits. Its new period is 2 pi over 2, which is pi, which is 180. So the P new formula is just the period over frequency, therefore pi. It's just the period divided by frequency, which is 180. The 2 says 2 visits once, twice, for 360 or 2 pi. So this is a good thing. So, by the way, graphing in trig, way easier than any other subject. So if you're finding this relatively easy, that's because it is easy. I hate graphing cubics, I hate graphing quadratics. The only thing I actually like graphing are lines, exponentials, and logarithms. Otherwise, all other graphing is painful. But I'll tell you what, trig graphing, it's great sport. So here, I'll just do another one. Y equals cosine pi x. P new is 2 pi over pi. Of course I want to work in radians. Got a pi there. I don't want to work in degrees because there wasn't a nice number there. If there's a pi, I'm going to stick in radians. So cosine 1, 2, 3, 4 has 1 cycle and 2 units. And cosine starts up and ends the same. Now, it says it's 3.14 visits per 2 pi, which equals 6.28. Now, I don't think I can squeeze it on there. Let me cheat a little bit. 4. So 4, 6. So tick, 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 tick. I'm about ready to destroy all of our papers. So there's the second visit. There's the third visit. And maybe one more tick. So that's right there. That's 6.25 at 6.28 to there. That's 0.28 of a visit. Pretty cool. 1Z, 2 visits, 3 visits, and a little more. But would we actually do that? No, we just stopped right here. Woo! None. I graph cosine pi x. Just 1, 2, 3, 4, put a 2. You know, and there is 3 visits for 2 pi, but I don't want to graph it. Anyway, it's a lot of fun. I'm going to do one more. Y goes 3/4. Whoops, that's the wrong spot. Let's try that again. Cosine 3/4 x. The period is 360 divided by omega, which is 360 over 1 times 4 over 3. This is 120, and this is 480. So sine repeats every 480 degrees. 1, 2, 3, 4, 480. And the sine starts low. Now, we know that this is 240, and we know this is 120, and we know this is 360. Frequency, omega, the number in front of the x, is 3/4, which is 0.75 of a cycle. So right here, hit the brakes at 360. There's 3/4 of a sine cycle in 360. Exactly what it says. Could I have worked in radians? Yep, no problem. Radians would have been just as easy. Now you can be a cheater and just go 2 pi. That's 460, so 4 pi over 3. This is 160, 260, so 2 pi over 3. So 2 pi over 3, 4 pi over 3, 6 pi over 3, 8 pi over 3. You can be a cheater and graph it in radians like that. Do it in degrees, convert all the scales. And by the way, this is 1. This is -1. By the way, that's the hardest part about the lesson today. That front number out front, A. So, y equals 5 sine x. Notice the frequency is 1. P nu, it doesn't really have a P nu. It's 2 pi over 1. Hey, guess what? The period's still 2 pi. This is the vertical scale. Now, there's 2 ways to do this. We're going to teach you the fast way first, and then we'll actually teach you what's going on. So, all you have to do is graph the sine scale, the sine, like you always do, and make sure the vertical scale is 5. So, ready? 1, 2, 3, 4, 2 pi. Tick high, tick low, graph sine. Switch that to a 5. Done. Now, is this what we do in algebra? No, that's not what we do in algebra. In algebra, we're saying 5 times the y value. All the y values are going times 5. So if you were to take the sine graph, 1, 2, 3, 4, 2 pi, 1 high. In algebra, they would say multiply the y coordinate by 5. So this is 1 times 5 is 5. This y value is -1 times 5 is -5. And 0 times 5 is 0, and 0 times 5 is 0, and 0 times 5 is 0, and we get the graph. So yes, the 5 does still stretch it like always. But really, if you want a quick graph, you just say the new vertical scale is 5. There is no difference between the 2 graphs, it's just that one you actually see it being stretched. The other one, well, obviously you don't. This looks like the same graph as before, you're just switching numbers. And that is why trig graphing is fun. You do have to understand that it is getting stretched, but you don't have to actually draw it stretched. You don't have to draw it compressed, but you do need to understand that it is compressed. So, let's have some more fun. So, y equals -3 sine 4x. V scale is 3. V flip, because the negative flips the graph vertically. P nu is 2 pi. The number in front of the x is called omega. So, before you do this, you got to say to yourself, I need to graph sine flipped. 1, 2, 3, 4. Graph sine flipped. Its new period is pi over 2. Its new scale is 3. Yeah, I got stretched vertically. Got stretched up to 3s. Yeah, I got compressed big time, because there used to be 1 cycle per 2 pi. Now there's 4 cycles per 2 pi. So this bad boy really got compressed times 4 from where it was before. So lots of fun. Hey, let's graph another one. Y equals negative 14 cosine 2 pi x minus 1/2. Hey, that's just left 1/2. Sorry, I'm a right-hander. I'm a left-hander. So it's opposite what we think. That's a right 1/2. Since I'm a lefty, I say it's a negative thing to be right-handed, but that's kind of unfair since most of you are right-handed, but we'll go with that. I'll insult you so you remember it. Anyway, I don't care about right 1/2. I can hire like a third grader to shift a graph 1/2 for me, so let's not worry about that piece. That is the omega. And P nu, if it's pi, I'm going with radians, and I traditionally graph in radians unless forced to graph in degrees. Anyway, it's 2 pi over omega, the formula, so it's 2 pi over 2 pi, which is 1. The negative is a V flip, and the vertical scale is 14. Now, before I forget, for sine and cosine, for sine and cosine, vertical scale equals amplitude. The magnitude of the wave. How big is the wave? The amplitude of the wave. But it only works for sine and cosine. So I call it the vertical scale because that works for all 6. But for secant, cosecant, tangent, cotangent, there's no such thing as a vertical scale. There's no such thing as an amplitude. But only for sine and cosine do you call it amplitude, and make sure you always call it positive, because a wave can't have a negative amplitude. It is so big. It's like absolute value of the front number. Anyway, the amplitude is 14. So you go 1, 2, 3, 4. The new period is 1. Flip cosine. And vertical scale 14. Now, this is 1/2. This is 1/4. This is 3/4. Now, do we actually feel like shifting it? We got to shift it right 1/2. Well, I do feel like shifting it right 1/2 because 1/2 is 2 ticks. So I need to go, let's talk to ourselves. This is right 1/2. So I take this point and I go tick, tick. I take this point and I go tick, tick. I take this point and I go tick, tick. I take this point and I go tick, tick. I take this point and I go tick, tick. And then I get a pattern. Look at me. I graphed that function no problem. Like when I'm lazy, I just say shift it right 1/2. So I know you can visualize shifting it 2 ticks, so sometimes I feel it's a little stupid to shift it 2 ticks, but you'll find in MML, you can't get away with it. I mean, you got to actually do the work. So if you're in a traditional class, you know, this would be fairly easy, but you're in the online class and they'll actually physically make you shift it. They'll also exaggerate like amplitude, so 14 may be just really up there, where here I draw everything to scale. Anyway, let's do another. This is so much fun. Y equals 11 sine 2/3 x minus pi plus 22. Now, let's be honest. It looks like sine. I can start graphing it right now. No flippy out front. 1, 2, 3, 4. Um, 11 high, 11 low. Looks like sine. Now, that's right pi. So I got to shift it right pi. This is up 22. Do I feel like shifting it up 22? Well, yeah, my ticks are going by 11. You know, will it end up in my problem? Sure. So I may or may not shift this. But I can shift it up 22, no problem. But the one thing I haven't done yet is calculate P new. P new is 2 pi over 2/3, which is 2 pi times 3 halves, boom, boom, 3 pi. So this is 3 pi, because it's the fourth tick, the new period. It repeats every 3 pi, making this 3 pi over 2, making this 3 pi over 4, making this, I don't know, 3 pi over 4, 6 pi over 4, 9 pi over 4, 12 pi over 4. I don't feel like shifting it right pi. I know what right is, but how big is pi? This is 3/4 of a pi, and this is 1.5 pi. It's in there somewhere, but I don't really feel like shifting it because the units aren't quite right. So in lecture, I know I'm going to be shifting it right and up, no problem, 2 dots up, but the amount right, I just don't feel good about it. So I'm like, oh, good enough. I'm happy. I know what's going on. I got this. Now, if you were to cheat and use it to kind of help you in MyMathLab, your calculator does it. So 11 sine, oops, yeah, parenthesis, really a bracket, 2 divided by 3. Hold on, I want to get this right. Parenthesis 2 divided by 3. Then I'm going to put a parenthesis x minus pi, parenthesis, parenthesis, plus 22. Now you got to know something about what's going on. So you need to do mode. You got to cheat in radians. Step 1, switch back to radians. Window, you know you want to graph it from 0 to 3 pi. So you can't let the calculator just do what it wants to do. Now, if you want your cool ticks, you want to go every 3 pi over 4. Now, we know we don't want to go minus 1.5 to 1.5. Initially, we want to go minus 11 to 11. And then we're going to shift it up 22, so we know we want to at least get up to 33. So I like the minus 11, but let's actually take it up to like 44. And then the Y scale, well, I'm going to go by 11s. And then I'm going to graph it. Uh-oh. Not good. Did my mode not switch? Oops. There we go. Let's try that again. There's the official final answer from 0 to 3 pi, negative 11 to 44. On MML, you know, I could, you know, basically just hold that up and like guess what graph it is. It's kind of called cheating. You don't want to be this person. You don't want, like, I like delete this, and delete the 22. That's kind of the graph I graphed. You know, from minus 11 to 11 to 3 pi. And then, here's a trick. you can actually shift it pi and up 22, the last graph. This is my first time doing this. I'm going to try to get a y1. So you go bars, y bars, function, y1, parenthesis, x minus pi. So it says shift the last graph pi, shift the last graph up 22. And I think you can get them both on the same axis. Yeah, pretty cool stuff. Should I show you this stuff? Well, of course I should show you this stuff. Who else is going to show you this stuff? You know, plus this is kind of the beauty of the online class. If I'm doing all my calculator examples, you know, granted I'm zipping through them, but you guys can hit pause. In a regular class, you're not going to get that. You know, there's no pause. You know, I'm firing through this, but you guys, you know, this is a nice valuable weapon. It's like having a solution key right there. But at the same time, you definitely want to learn how to do it by hand. Just hurting yourself, not learning. Now, they mess with you in the book. They give you stuff like y equals -3 plus 2 sine 3x. And they say graph it. That's because they write it in the wrong order. 2 sine 3x minus 3. That's down 3. There is no left, right. But omega is 3, and the VS, the vertical scale, not Victoria's Secrets, is 2. But if it's sine or cosine, you say the amplitude is 2. Anyway, I'll zip this out. Oh, forgot it. Go P nu is 2 pi over 3. Hey, let me switch. Let me go 360 divided by 3. 120. So I go 1, 2, 3, 4, slap down to 120. I'm supposed to graph a regular sine, no flippy flippy, jump, and no right left. The vertical scale is 2. Three, 4, 5. Do I feel like shifting this graph down 3? Well, sure I do, because my scale worked out. So I'll take this one and go down 3, that one and go down 3, this one and go down 3, this one and go down 3, and this one to go down 3, and I'll graph my function on 0 to 120. Obviously, there's 3 cycles in 360 because the 3 is saying there's 3 cycles in 360. Now, is it stretched from my original graph? Well, yeah, my original graph looks like this. Yeah, you see the stretch? But I don't care about that so much. I just want to graph one cycle of the trig function on with the correct vertical scale, basically. And I can graph everything in trig, no problem. Now there's the messed up problem, the one where they mess with you a little bit. It's like 5 cos 2x minus 8 plus 3. It's not in proper form. Proper form is 5 cos 2 on the out x minus 4 plus 3. So this graph has amplitude, which is equivalent to the Victoria's vertical scale, is 5. It has omega of 2. It has a P nu of I'm fine with radians or degrees, but since there's no degree symbol right here, and there's no degree symbol right there, technically you're shifting it left or right in radians, so we must work in radians. The new period is pi, makes sense because it oscillates twice in 0 to 2 pi, so the period new being pi makes sense. A little up 3. Do I want to graph it? No, because it's the same thing we just done 5 times. Now, what's the trick? What's the worst problem? When they go negative 14 sine 2x minus 3 minus 11. Now, don't be telling me write 3, because it's not proper form. The 2's got to pull out. And you're like, how can I pull out a 2? There is no 2 right there. Yeah, there is. See that 2 over 2? There's a 2 there. So I'm going to lasso this 2 and lasso that 2. I'm going to rip it out, and you see the 3 halves? That's what you do. Minus 11. So the amplitude is 14. The period is 2 pi over 2, which is pi. We go right 3 halves, which is 1.5, down 11. That is it for today. I crushed that. Good luck when you work 9-6 MML. This is one of these times where I wish we could just work a ton of book problems. And, you know, MML is great, and you'll learn a lot because it'll keep you honest. But for right now, we're trying to keep this class pretty streamlined. So good luck. Figure it out. Like I said, I'm working them all the sections today. Hoping to work sections 9.2 through 9.7 actually. And then one more lecture, I believe. I'm going to lecture over 9.7. And most likely, I'll probably give a review lecture for the whole chapter. Well, actually, there's a section 9.8. It's called harmonic motion. I'm not sure if I want to cover that. I might turn around and cover that at the end. It's an optional section. So I might do a review lecture over all chapter 9. And that's about it. Hitting my 38 minute mark. So that's all I'm going to do today. See you later.